Hello again, welcome to tutorial 6, radio transmitters. We're going to be discussing basic AM and FM transmitters in this tutorial. To make radio transmission possible, we need to generate a radio frequency signal. To do that, we use a device called an oscillator. An oscillator just generates for us a sine wave at a particular frequency. This slide shows the two possible ways of presenting an oscillator in a block diagram. The one that you're likely to get in your assessment is this one. And what an oscillator does for us is it produces a radio frequency sine wave, but it could also produce a audio frequency sine wave. In fact, an oscillator can produce sine waves for us at any frequency. So if we wanted sine waves at 1 megahertz, we could achieve that easily with an oscillator. If we put a 1 megahertz signal into an antenna, it will radiate. So if we were to put an antenna on this oscillator, we would have a very simple transmitter. Because all the oscillator's doing is, let's say it's producing a 1 megahertz sine wave. Well, 1 megahertz, if fed into an antenna, will radiate electromagnetic radiation, radio waves. However, an oscillator to do that needs a power supply. So, because an oscillator can't produce something out of nothing, so we need a power supply. So what you're looking at now in the very simplest form is a radio transmitter. A power supply and an oscillator is the simplest form of radio transmitter. Not incredibly useful, but it will transmit, and just forget that symbol for now. That is the simplest radio transmitter. What I'd like you to do is remember that an oscillator is a source of sine waves at any frequency you want. They could be audio frequencies, but in radio transmitters, our oscillators are normally operating at radio frequencies. And the most simplest transmitter that you could have would be a power supply, an oscillator, and an antenna. Not a very practical transmitter, but let's turn it into one. If we take the oscillator we had a moment ago, and remember an oscillator is a source of radio frequency or audio frequency energy, but in this case radio frequency energy. Let's suppose it's oscillating on 1 megahertz. So that oscillator will put a signal into the antenna on 1 megahertz, but there will be no information on that signal. And the way we say no information in radio is we say no modulation. So if we just had this oscillator, it would just transmit a radio frequency sine wave on 1 megahertz. And if someone received that, they wouldn't hear any sounds, they wouldn't hear any information, they would just see a deflection of the signal meter on their receiver, and that would be all. But suppose we just add one more device. Suppose we add a telegraphy key, a Morse key, into this position. Now we've got the ability to turn the oscillator on and off. So if we prearrange a code with another operator, we could turn the key on and off and send him messages. And of course, the code we use is Morse code. It's a universal international code. And by operating the Morse key in the right pattern of ons and offs, we can transmit a plain English message or any other message to another station. That's a basic telegraphy transmitter. A power supply, a Morse key. The Morse key turns the oscillator on and off. The oscillator radiates a signal on whatever frequency we want, and the Morse key turns that signal on and off according to a code, and by that method we can transmit messages to other radio operators. We've learned that we can transmit a radio signal if we just have an oscillator, and if that oscillator is connected to an antenna, and we can transmit messages by turning that oscillator on and off in a telegraphy transmitter. If we want to transmit voice, we need another stage called a modulator. Now let's talk about the principle of modulation first. Modulation is when we mix audio. This is audio. Let me fix that. Sorry about that. Fixed it. Okay. Modulation is a process by which we take audio from voice. So this is our voice going into a microphone and being amplified. That's all that is. And the oscillator is a radio frequency signal source. RF signal source. Let's imagine it's on 1 megahertz, just for imagination's sake. When the radio frequency on 1 megahertz from the oscillator and the 0 to 3 kilohertz from our voice, because that's the voice frequency range, goes into the modulator, the amplitude of the carrier, the amplitude of the oscillator is made to change according to our voice. So we are superimposing onto the transmitted carrier our voice by changing the amplitude of the modulated carrier. That's what the modulator does. This stage is nothing more than a radio frequency amplifier. That's a radio frequency power amplifier. So we need that because the output of an oscillator is very, very low. The output of the audio amplifier is very, very low. So at this point here, we've actually got the signal that we're going to transmit. We're going to be transmitting amplitude modulation because the audio from the microphone is mixing with the carrier from the oscillator in the modulator to make the amplitude of the modulated signal change. That's called amplitude modulation. There are a number of different types of amplitude modulation. A type that you could be familiar with is single sideband. Single sideband is amplitude modulation. Ordinary AM radio is amplitude modulation. Let's have a closer look at our AM radio telephony transmitter. The oscillator is producing a radio frequency carrier, a radio frequency sine wave, and that's what it looks like. This is a radio frequency. So if this was 1 megahertz, there would be 1 million of these every second on the horizontal axis. So the radio frequency oscillator produces a radio frequency carrier, a sine wave, on whatever frequency we want. So that's the oscillator. The microphone produces audio frequencies. You can see that this is a much lower frequency than this one. So this is the frequencies for the microphone. It wouldn't be a sine wave, it'd be all higgledy-piggledy because voice doesn't produce a sine wave. We've just done that to simplify it for you. The actual audio would be far more complicated than a sine wave. So the audio is converted to an electrical signal there, and the radio frequency carrier here, and in the modulator, the two are combined, and the result of that combination is an amplitude modulated carrier. Can you see this is the carrier here, or an amplitude modulated signal more correctly? This is the unmodulated carrier. This is the audio from the microphone. When we put the two together, you're quite clear that the amplitude here is level. There's no change in amplitude there, but here there's now a change in amplitude, and that change is in sympathy with our voice, and we've worked out a way of transmitting radio telephony on radio, and that method is called amplitude modulation, because the amplitude of the modulated signal is being varied when we speak with our voice. What I've done in this last slide is just to show you the two transmitters that we've been talking about. The basic telegraphy transmitter needs a power supply. By the way, there's no power supply shown in our AM transmitter. There would be a power supply, but in your assessment, no power supply will be drawn. Basic telegraphy transmitter, power supply, supplying all the power, a Morse key to turn the carrier produced by the oscillator on and off. That's it. The oscillator produces radio frequency energy. The Morse key turns the oscillator on and off, and the power supply supplies all the power for that. That's a radio telegraphy transmitter. A radio telephony transmitter, we need a microphone, we need a microphone amplifier or audio amplifier. We still need our oscillator to produce the carrier. The audio and the carrier are mixed in the modulator in such a way that the amplitude of the transmitted signal is made to change. That's called AM transmission. The only function of the power amplifier is to lift the power of the output of the modulator to a few watts or 100 watts or whatever we need before we go into the antenna. So that's just an amplifier. They're the block diagrams that you need to know for your foundation assessment in respect of radio transmitters. There is another way to modulate a carrier with a voice. On the left-hand side, we've got the method that you need to know the block diagram of, the one we just discussed, that is amplitude modulation. It's called amplitude modulation because it's the amplitude of the transmitted signal which is changing. Do you notice the frequency of the unmodulated carrier? It's the same frequency as the modulated carrier. So nothing's happening in terms of frequency change here with modulation. What's happening is the amplitude of the carrier or the transmitted signal is being changed with modulation. There is another method. We can leave the modulating audio the same, leave the carrier the same, but notice this time what's happening is the frequency of the carrier is changing, not the amplitude. So the audio is being mixed with the carrier in such a way that the frequency is changing. This is a lower frequency here. They're all bunched up here. That's a higher frequency. That is called frequency modulation. So with amplitude modulation on the left, it is the amplitude of the transmitted signal that is changing, and with FM on the right, it is the frequency of the transmitted signal that is changing. AM and FM have particular advantages and disadvantages. How much the frequency is changed is called the deviation. So if we had no modulation, the carrier would be on, say, 1 megahertz here. When we start talking, the carrier changes frequency above and below 1 megahertz, and the amount by which it changes above and below 1 megahertz is called the deviation. FM signals tend to be a larger bandwidth than AM signals. That means they take up more room in the radio spectrum than do AM signals. A typical amateur FM transmission is 16 kilohertz wide. A typical amateur SSB transmission is 3 kilohertz wide, and double sideband, which is what most people call FM, is about 6 kilohertz wide. Well, that's it for basic transmitters. We'll be doing a little bit more later. We'll be talking about the controls on transmitters and how to use them, and receivers. I'll see you back in the next tutorial where we're going to be discussing basic radio receivers. Good luck with your course. Thanks for your attention. Cheers for now. This is Ron, VK2DQ.